Okay, the next one looks like we're starting to get into some inequalities. So let's go ahead and work this. And what you're going to do is you're just going to work both sides. Work it on down. So we're going to have 5 minus 5x is greater than or equal to 5, or a minus 8x plus 8 is less than a negative 24. So what we're going to do here is we want to get the 5x alone. So I am going to subtract 5 from both sides. Minus 5 minus 5. I have a negative 5x is equal to 0. Now that I'm going to divide, oops, it's not equal to, it's greater than equal to. Now I'm going to divide both sides by a negative 5. When I do that, I'm dividing by a negative. This inequality will switch. So negative 5 by negative 5 is x. This would be less than or equal to 0. Okay, and on the other side, let's go ahead and work it. I am going to subtract 8 from both sides. And that's going to give me a minus 8x is less than a minus 32. Divide both sides by a minus 8. Dividing by a negative again is going to cause that inequality to switch. I would have x is greater than a negative 32 divided by 8 would be greater than 4. So this was an OR. So I'm bringing the OR down, and here is the algebraic part of my answer. Now let's graphically do that. So remember, what I said is you plot this and plot that, then you combine them. So the final answer will be on the number line. X is less than or equal to 0. That would be a closed dot. And x is less than or equal to 0. And the other side is x is greater than 4. So that would be an open dot. And since this is an OR, it's the union of the two. So the union of the two would be exactly what's below. And that would be my final graphical answer. Let's move to the next one. Now this is an AND. And I'm going to go ahead and work this. You could break this up and say 21 is less than a minus 6 minus 9x, and a minus 6 minus 9x is less than 48, and working as an AND. I'm going to work it all in one because it's already in a shorthand form. Remember, you can't do this if it's an OR. Okay, my first step is going to be to add 6. If I add 6 there, I have to add 6 here, add 6 here. It's 27 is less than negative 9x is less than 54. Next, we're going to get rid of the negative 9, so divide by a negative 9. Now notice that I'm dividing all three pieces by a negative. That's going to switch this inequality sign on both sides of this x. So the inequality sign flips. 27 divided by negative 9 is a negative 3. Now this inequality sign flipped. This is going to be x. And over here, this would have flipped. 54 divided by 9 is a negative 6. So rewriting this to look a little different, we have a negative 6 is less than x. And x is less than a negative 3. So that's how we could write that. I kind of got that messed up there. Okay, so let's plot x is greater than a negative 6. Open dot, going to the right. X is less than a negative 3. Open dot, going this way. And since it's an AND, it is the intersection, the overlap of the two. So the final solution is plotted on the number line would be open dot, and everything in between. Okay? I guess we only have 2 more left. 34 problems. Okay, so let's go ahead and do these absolute values. Now remember, you need to get the absolute value all alone before you can get rid of the absolute value by changing it into a compound inequality. So I'm going to divide both sides by 9, and that's going to give me a negative 4v in absolute value plus 8 is less than 12. All right, now I have the absolute value isolated. There's several things that happen. This is a less than, so I can see this is going to be an and. I'm going to break this absolute value up into 2 compound inequalities, and the absolute value will be gone. It'll be the positive of what's ever in there is less than 12, and everything in there could be negative, so it'd be a negative of what's ever in there. Also has to be less than 12. Okay, so on this side, I am going to go ahead and subtract 8 from both sides. So subtracting 8 from both sides, I get a minus 4v is less than 12. On the other side, I'm going to divide both sides by a negative 1. That would take this negative and move it to the other side when I divide by a negative 1. But it would also, because I'm dividing by a negative, cause this inequality to switch. And the next step over here would be divide by a negative 4. So I'm going to divide this by a negative 4, gives me v. I'm going to divide this by negative 4, would give me a negative 3, but the division by a negative 4, once again I'm dividing by a negative, would cause the inequality sign to switch. Circle my algebraic answer up there. Over here, I'm going to subtract 8 from both sides. So I'll have a negative 4v is greater than a negative 20. I'm now going to divide both sides by a negative 4 over here. This side is done, so I'm just going to go ahead and carry my answer down. And over here, when I divide by a negative 4, this becomes v. Negative 20 divided by a negative 4 would be a positive 5, but the division by a negative 4 by the negative causes that inequality to switch. So I have an and. I have v is less than 5. So let's go ahead and put v is less than 5. That's an open dot. That's where v is less than 5. V is greater than a negative 3. That would be down here, going this way. And I'm going to extend this arrow a little bit. And you can see that what's going to happen is it's an and, so it's the overlap. The overlap starts here at that open dot. It's overlapped to up here, and there's the intersection. Okay, let's do the next one. So what I'm going to do, and I need some room for this, so basically I'm going to divide this side by a negative 7 and this side by a negative 7 to get the absolute value isolated. So divide by a negative 7. That's going to leave this absolute value as this. Minus 1 minus 4a. All alone. And when I divide the negative 49 by negative 7, that's going to be 7. But when I divide by a negative, the inequality switches. So this is going to be a greater than or equal to. So now, once I've isolated the absolute value is when I make a determination whether it's going to be an and or an or. This is a greater than, so this is an or. And one side of the or is going to be the positive of what's ever in there. And the other side of the or will be the negative of what's ever in there. Okay, so on this side, I am going to add 1 to both sides. On this side, I am going to divide by a negative 1. When I divide by negative 1, that leaves me with a negative 1 minus 4a. It's going to flip this inequality, and it's going to put a negative on the 7 because it'll divide by a negative 1. This side now I'm going to divide by a negative 4. When I divide this side by a negative 4, this becomes a. The negative causes the inequality sign to switch, and dividing 8 by the negative 4 gives me a negative 2. This side I'm going to add 1. So I'm going to add 1 to this side and 1 to that side. So I have a minus 4a is less than or equal to a negative 7 plus 1 would be a negative 6. Now I rewrite that because that side's done. This side I'm going to divide by a negative 4. When I divide by a negative 4, this is going to become a. The negative will cause the inequality sign to switch, and I would end up over here with a negative 6 over a negative 4. Negative 6 over negative 4 would be a positive 3/2 if you simplify that fraction. So here's my algebraic answer. I'm going to circle it. Should have circled this one. Move them off the page. And let's plot it. We're going to have a is less than or equal to a negative 2. Or a can be greater than 3/2. Greater than or equal to 3/2. So let's go that way. And since it's an or, it's going to be those two combined. So that would be my answer. I think that's the end of the practice test.